All right, so now we're here on the back of the notes. We're here at problem number 5. And now we have variables on both sides of this proportion, in both denominators in this case. Well, let's cross multiply. It doesn't matter which diagonal I do first. I'm going to do 2 times the whole expression 20x plus 3 equals, I'm going to write the 5 in front of the parentheses. I always want to put this number in front. 5 times 4x minus 1. Now to solve this, we're going to distribute. So I'm going to distribute the 2. That's 40x plus 6. And this is going to be 20x. Now that's 5 times negative 1 is minus 5. Okay, so now I need to get the variables on the same side. I'm going to move the positive 20x by subtracting it on both sides. So that's 20x plus 6 equals negative 5. Now, since I moved the variable to the left, I need to move the constant to the right. I'm going to undo addition by subtracting minus minus. 20x is equal to negative 11. And then to undo the multiplication, the coefficient, we divide at the end. Now in this case, we get a fraction, negative 11 over 20. If you want to convert that to a decimal, you can. It's negative 0.55. Now one thing that I can do using this calculator, when I check this is a little bit more complicated to check. So what I'm going to do in this case is take my answer, I'm going to store it. Okay, so there's an STO button, store, for x. And then I can actually type the two ratios as fractions on my calculator. So let's see, it was 2 over 4x minus 1. Now the calculator is going to substitute the negative 0.55 for me. And there's the value, left side. Then the right side is 5 divided by 20x plus 3. Now, negative 5 over 8 is how it writes the answer. And if I change that to a decimal, okay, same thing. So that's how I know that we're good, that we're correct. In number 6, now we're going to look at some word problems here. A car can travel 216 miles on 8 gallons of gas. So we've got 216 miles, 8 gallons. How far can it travel on 12 gallons? So they give us 3 different values and they're asking for a 4th value. When you're dealing with this kind of comparison, we want to think about ratio and proportion. Now there's a bunch of ways to set this up, but I'm going to compare miles to gallons. And the way I'm comparing is with a fraction, miles over gallons. So I know I'm going to make a proportion here. There are 4 places. Well, on the left side, I can say 216 miles for 8 gallons. So there's miles and gallons. They give us one other number, 12 gallons. Now, since I put gallons on the bottom of the fraction on the left side, I have to be consistent and do the same thing on the right side. So the 12 has to go here, which means that this is our missing value, how far, the distance, that's my x. And so then we cross multiply, now we can solve it, and we get 8x equals 216 times 12, which is 2,592. And to solve it now, we can divide by 8. And we get 324. Now this is miles, and that's important that I use my units of measurement right there, because that's different from kilometers, meters, inches, different types of measurement. Now you may have looked at this and you may have put the 8 on top of the fraction. You may have done gallons over miles. That's fine. If I had said 8 over 216, as long as I'm consistent, if I do gallons over miles for the left fraction, I have to do gallons over miles for the right fraction. So I could have done it this way, and notice I would have had 8x again, and 216 times 12. So that would have worked out. So the thing about being, when you make a proportion, when you set it up, you have to be consistent with your measures. You have to be consistent. Okay, let's take 7 here. In 2018, an ounce of gold was worth $1,200. Today it's worth $2,046 per ounce. Wow, that's a huge increase. If you have 3.5 ounces, how much more is it worth today than in 2018? Now again, there's different ways to look at these problems. So you don't have to do a proportion to figure this out, but I'm going to set it up that way. Now, you'll see there's a lot of numbers here. There's the 2018, there's the year. Now that's the one number we're going to ignore, because what we're really comparing is the price and the ounces. Okay, so we have a price, it was $1,200, now it's $2,046. And then we have the ounces here. So back in 2018, we knew the price was $1,200 for every 1 ounce. So I'm going to do dollars and ounces here. $1,200 for 1 ounce. Okay, so let's start with 2018. If we had 3.5 ounces, how much would that have been worth? Well, now 3.5 is the ounces. I'm putting ounces on the bottom, which means that X goes on the top. And now I can solve this. We can cross multiply 1 times X. Well, that's just X. And then if we multiply 1,200 times 3.5, we get $4,200. So in 2018, 3.5 ounces was $1,200. Now today, though, the price of gold has gone up significantly. Now it's $2,046 per ounce. So now 2,046 over 1 ounce. If we had 3.5 ounces today, how much would that be worth? Well, we can make this proportion. And basically what we're doing is we're taking the cost per ounce, the price, and we're multiplying by the number of ounces. So again, you could have done this without making a proportion. You can think your way through this problem. So that is worth $7,161. Wow, that's good. The question is, how much more is it worth today than in 2018? So this was the key. This is why we needed 2 separate proportions, because we were looking at 2 situations, 2018 and then the year 2020. How much more is this worth today? Well, that's a subtraction problem. So we'll take 7,161, we'll subtract 4,200, and that will give us a difference of $2,961. Okay, so that's the key. We have to interpret the word problem. They're not asking us just to find what it's worth. They're saying, what's the difference? How much more is it worth today? All right, we've got 2 problems left here, and these last 2 are going to deal with what we call conversion. So how we can change from one unit of measurement to another. So to convert, we're talking about change in units of measurement. So in number 8, we're going to talk about speed. A driver's speed is 100 kilometers per hour. Convert this to meters per second. So we want to go from 100 kilometers per hour to meters per second. Now I'm going to write this as a ratio, 100 kilometers for every 1 hour. At the end of this, we want to get something meters for 1 second. This is our goal. Now notice that we're starting in kilometers, but we have to end up in meters. And we're starting in hours, but we have to end up in seconds. The way that we're going to do this is we are going to set up a system of ratios that we're going to multiply. And just to, on the side here, I'm going to come back and do a little review of multiplying fractions. This is example, EX. I'm just making this up. If I take fractions and multiply them, the rule is when you multiply fractions, you multiply the numerators together, and then you multiply the denominators. So we would do 1 times 2 times 3 times 4 times 5 and get a value, and then we would do the same thing with 2, 3, 4, 5, and 6. But if we do it like this, this would end up being 20, 60, this would be 120. This would be, let's see, 30 times 4 is 120, 360, 720. And then we'd have to simplify this to come up with a final fraction. An easier way, instead of multiplying first, we could actually divide the numerators and denominators. I can think of this as one big fraction. I can divide out 2 and 2. I can do that first. 2 divided by 2 is 1, which basically goes away. 3 divided by 3 is 1. 4 divided by 4 is 1. 5 divided by 5 is 1. And notice that all that leaves us with is 1 on the top and 6 on the bottom. And just to show you, if I take 120 divided by 720 and change that to a fraction, that is 1 over 6. Okay, so I can do this kind of problem faster. The idea is that I can cancel out the common values. Now I'm going to do the same thing here with the units of measurement. So if I want to take kilometers and change that to meters, well, we know 1 kilometer is equal to 1,000 meters. So I'm going to write it this way because if I have the same measurement in the top and the bottom of the fraction, when I am multiplying, I can reduce that. Basically cross that out, and now this would become meters per hour. But I don't want hours, I want seconds. Well, let's take hours and convert that to minutes. Now 1 hour, let's see, hours are on the bottom, so I got to put an hour up top. 1 hour is 60 minutes. Now I can cross these out, I can reduce those, kind of cancel those. So now what we have is meters over minutes. We don't want minutes, we want seconds. Now I know a seconds has to be on the bottom, so I'm going to do 1 minute, 60 seconds. Minutes I can now reduce. And so what we have here, this is meters per second. It's 100 times 1,000. And then over, this would be 60 times 60. Okay, so if I'm using the calculator, I'm going to type it as a fraction. So we've got 100 times 1,000 up top, and then 60 times 60 in the bottom. 250 over 9. So 250 meters for 9 seconds. But actually, I don't want to write it that way. That's not how we talk about velocity. So let me change that to a decimal. So if I divide that, because I don't want it over 9 seconds, I want it per 1 second. So that would be 27.8 approximately. 27.8 meters for 1 second. And the way we write that, we write it this way, meters per second. And there's your velocity, your speed. Now we're going to do one more here, and we're going to go back to our example with gold. Gold is $2,046 per ounce, but in the UAE, we would like to know what this is in dirhams per gram. Okay, so we're going to start with $2,046 for 1 ounce. Now it's up to you how you want to start the conversion. If I want to take ounces to grams, so first of all, since ounces are on the bottom, I'm going to have to put them on the top here. So 1 ounce, and I looked this up, an ounce is 28.35 grams. Okay, and then, so I can cross out ounces. So now we have dollars per gram. We need to convert that to dirhams. Since dollars is in the top of the ratio, I'm going to put it in the bottom here. So $1, and that is equal to 3.67 dirhams. And now we can multiply the fractions. So we would multiply the numerators together, and then we'd multiply the denominators, and I'll set it up this way. So 2,046 times 3.67 over, in the denominator, it's just 1 times 28.35 times 1, so 28.35. And what we get is 264.9. I'll round that up to 0.9. 264.9 dirhams for 1 gram, dirhams per gram. And that is the end of the notes.